Hi guys, I would like to discuss a problem of finding the interval of concavity. So the function I have is x squared over x squared plus 25. I will use the quotient rule. Remember that like n over d prime is d times n prime minus n times d prime divided by d squared. So I will use this quotient rule to find the concavity of this function. Interval of, let's write this interval of concave down, concave up. Alright, so this compute the first derivative. So it's going to be x squared plus 25 times 2x minus now x squared times derivative of x squared plus 25, which is 2x again, all the way down divided by x squared plus 25 squared. Alright, let's distribute and then see what happens here. The first one becomes 2x cubed. The second one is 50x. And over here we have, if you multiply this 2, this would be minus 2x cubed divided by x squared plus 25 cubed. You can see some cancellations in here, so we can cancel this 2. And we are left with 50 times x divided by x squared plus 25 cube. Oh, squared. Why did I write cube there? These are squared. Alright. Now let's differentiate this one more time. This is our f prime. Let's differentiate this, and to get f double prime using quotient rule again. So that would be x squared plus 25 squared times 50 minus 50x times, now using the chain rule to differentiate this quantity, it is 2 times x squared plus 25 to the power 1 times derivative of x squared plus 25 is 2x. All the way again divided by the square of the square. Square of the square will give you 4th power here. Now let's see the simplifications. Look at these terms in here. So this term is in common with this. So it appears over here. And also 50 is the common one. Look at this. So let's put this 50 times x squared plus 25 out there. So from the first expression, the factor of x squared plus 25 is left. And then from the second one, you get 2x in here times 2x, 4x squared, minus 4x squared. 2 times x times 2x, 4x squared, divided by x squared plus 25 to the power 4. So we know that one of the powers cancels this, so we have this. This will cancel this one, and you are left with 3 of them in here. And on the other hand, if I look at the x squared term and the negative x squared term in here, so we are left with 50 times x squared minus 4x squared is negative 3x squared, and there's 25 left, so 25 in here divided by x squared plus 25 cube. So this is our second derivative, f double prime. So this will be 0. As you see, the denominator is never 0. It's always bigger than 25 cube, actually. And because of the plus sign here, it is bigger than 25 cube. And then only numerator can be 0. 50 is never 0. So you have, this is the case whenever 25 minus 3x squared is 0, or 25 equals 3x squared. And then divide both sides by 3, x squared equals 25 over 3. And then take the root on both sides. If you apply the root on both sides, what do you get? we have plus minus sign, right? So when we do that, actually we have to put plus minus sign here. Okay, so x will be plus minus 5 over root 25 is 5, but square root 3 is going to be there, so let's keep it there. So 5 over root 3. So to find the concavity, I'm going to check the sign of this f double prime. F double prime here, so there are two values, negative 5 over root 3 and then 5 over root 3. So if you take, like, if you plug 0 in f double prime, where in here f double prime is this, if you plug 0, then 50 times 25 divided by this is a positive quantity. So if I plug 0, which is in this interval, so the sign is plus. And then if you plug, like they say in here, negative 5, and then this will be negative because of this. This is a very big number than 25. So that would be minus. And then this will be minus similarly because of the square here. So here the f is going to be so here concave down, concave up, and then concave down again. So the f is concave up, on the interval negative 5 over root 3 and then 5 over root 3, and then concave down on the interval from negative infinity to negative 5 over root 3 and union sign 5 over root 3 to plus infinity. So on this interval. Alright, that's it. I hope this helps. Thank you very much for watching.